Okay, so we are back. Nita, I just saw your question. Repeat the question. I already went over it, so sorry. So that question had to do with the load average over the past 1, 5, and 15 minutes. What I would like to do is basically explain that. So if, actually what I can do is I can do with the whiteboard. Not you. Not you. Is it not? No. Not something. Oh, I can do it like this. Okay. So if what we see is in a load average situation, why is the whiteboard not working? Okay, there we go. Technical difficulties. Okay, let me switch back out of this thing. It's working. Okay, so if what we see is kind of a wow, it's really not wanting to work well today. If what we see is over the past 1 minute, 5 minutes, and 15 minutes, okay, all right. If what we see is what we saw in the example, a low value here, a higher value here, and let me make a green be the one value here. Okay, so this is 1. Okay, if we see a higher value here and then yet another higher value here, then what we can say is over the past 15 minutes, the system has been becoming less saturated, less overtaxed, overworked, right? Because it was overworked here, but it's caught up, right? It's processing processes, but not getting a lot of new ones in, and processing processes and then not getting a lot of new ones in, even to the point that now we've got processes that generally are not waiting for a processor to become available over here. Okay, so we see a system that is being less overworked, less taxed. Okay, if we see the opposite going on, 15 minutes ago, says it was going well. Here, in the past 5 minutes, it's been around here, and in the past 1 minute, it's up around here. Then what we're seeing is a system that is becoming more overworking, more taxed, right? It was not having a lot of processes to deal with back 15 minutes ago, but in the past minute, it's gotten way out of hand, right? It's getting a lot of stuff going on. Okay. Right. This is not a good or bad thing. It's not that it's not to say that this is better than this or the other way around. Basically, it's just a matter of, is the system trying to do a lot at once? So right now, for example, I would imagine that if everyone who's supposed to be in this class were here on this call and had your cameras open and had your microphones on, we would be using a lot more internet, right? We'd be using a lot more internet bandwidth right now than we currently are, right? Is that a good thing or a bad thing? Well, it's neither. It's just how it is, right? It's just that when the system is being used more, it's going to have more wait times. It's going to take longer to process things. Okay, so when we get off this call, and everybody gets off this call, and you maybe go outside from your 1 to 4, you get to go outside time period for those of you who are under 20 years old, which I don't think is many of you in this class, right? But when you have that opportunity during 1 to 4 time frames, you know, during the next couple of weeks, right, next couple of months, you know, the internet will not be taxed as much as during the other times, right? Because kids will be outside, kids will be doing things not at home, not getting online, not watching videos, not watching classes and stuff like that. Okay, so this just tells us, is the system more taxed in the past and more overworked in the past, but getting, you know, more fast, more it's getting faster, less processes coming in, fewer processes coming in rather. Or this black type of example, this black line is, it was doing well, it was not being overworked, but now we've been sending it a lot, so it's being used a lot more. Okay, sometimes that can be an indication that, you know, people are running more processes. Maybe there are things that are not going well in the recent, right? It can be an indication of that. We just don't know that until we see other things. Okay. All right. Back to what we were talking about before. Okay. So now we're into chapter 8, and it does look like there's only 2 sections in chapter 8, and they're not really long sections. So we definitely will get into chapter 9 before the end of this lecture. Okay. All right. So let's talk about services and daemons. Okay. So the systemd command, right? The systemd will tell us how this processes are managed and how we can do stuff with them. Okay. For the most part, the names of many daemon programs, many processes that run in the background, right? That for the most part, many of them start automatically at boot time, and most of them continue to run until shutdown. They're just stuff that runs in the background. We don't know about them. We don't really, most users don't have a need to know about them, but they're the things that run in the background to keep things going smooth with the system that we don't have to think about. Daemons can be things that are like the stuff that controls your network card, so that you can connect to the internet. Daemons can be things that control who can log into the system. Daemons can be things that control all kinds of things. Your sound card, your just lots of things, right? And these are all things that you don't have to start. You don't want to have to start them. You just want the computer to do it on its own. And you don't think about it, you just let it do, right? So anyway, daemons, many of them end in the letter D by convention so that we know that they are daemons. Okay, it's kind of a one thing. It's like, oh, I know that's a daemon because it ends in D. Okay, let's see. I don't want to go through too much of the history stuff. Assuming that this is available on the HTML resources, somebody please tell me if it's not, because if it is, I will go ahead and get it to you. But it is kind of some interesting stuff here that I would like you guys to know about. Okay. So the system daemon, right? So we can control these things using the system control command, okay? Systemctl, to be able to help us control some of these system daemons and some of these services, okay? All right. So another thing is service units, services have a .service extension, okay, and we'll be representing system services. That's another thing. So D, a service that ends in D will be a daemon most likely. A thing that ends in .service is a service. Okay. So as an example, the SSHD, we're going to get into SSHD in chapter 9. So I want you guys to be familiar with this one to start off with. Okay. By the end of this next 10 minutes or so, you guys will know how to read all of the information that's here. Okay. All right, so we do system control status. So what's the status of this particular thing, the name.type? So the SSHD, the SSH daemon, it's a service unit. Okay. So here, when we run that system control status and we find out what the status information, right? So the SSHD service is the open SSH server daemon. So this is the information that tells us what this is. Okay. Is it loaded? Okay. So this tells us the information after this is going to tell us what it is. Is it loaded? Well, what we learned from this is yes, it's loaded and it's enabled. If this was not loaded, it would say unloaded, right? It wouldn't say loaded. And we'll find out what that means in just a moment. You will also know this is where to find it. And this is it enabled? And we'll find out what enabled means in just a moment. Is it active? It's active and it's running, and this is how long it's been running since. If this was not active, it would say stopped, and it would tell us how long it's been stopped. Okay. All right, so there's some other information here. The main information I want you to know from this, for this course, for this intro to system administration, is the stuff that's on these first three lines here. The SSHD service, like what is its, what is it? Right, server daemon, open SSH server daemon. Is it loaded? Is it active? Okay. I guess I do actually want you to know the process ID, because that's something important that'll come up in just a moment as well. All right, but these are some information that you need to know. Okay. I want you to be able to, for the exam, for example, coming up, well, I would want you to be able to read through this and tell me what these things mean. So be prepared. We're about to go into that. Okay. All right, so this is what those keywords mean. Loaded means the unit configuration file has been processed. Now, what that means is that there's a configuration file for that service. You guys remember the UMask stuff, right? We talked about UMask and how to change that. That's a configuration for UMask. And we talked about that last week. So if the configuration file changes, we need to reload it, okay? Because basically when a service starts, when a service runs, it uses whatever the configuration file is at that moment to understand how it should run, like what should its configuration be. If that configuration file changes while the service is running, it does not automatically go get that new configuration and start running according to the new configuration. It uses the old configuration. Okay. So for example, let's say that as far as I'm trying to think of something that changes, but we may want to use the old system. Okay. Well, let's say, for example, let's say my kids are on next week. They're outside playing, and it's 2:30 in the afternoon. Okay. If the government were to suddenly announce, oh, you know what, we made a big mistake, and it's not actually 1 to 3 that we want kids to be out, it's actually 4 o'clock to 7 o'clock that we want kids to be out. Okay. Well, if they said, and we want that to start right now, what would happen is I would have to then adjust I'd have to load that new configuration. All right. I couldn't leave my kids out, right? And I guess that may be a really poor example, a really bad example. But the idea is that if a service is running right now according to an old configuration, if the configuration for it changes that we want it to run based on, we have to stop that service and restart it in order to load the new configuration. Okay, I hope that's clear. All right. Okay. Some other things, some other information: that active running, active exit, active waiting. Okay. So if a service is active, it is currently running. Okay, it's currently executing. Not all services are running all the time. Some services are stopped. Right. So it could have inactive, which would mean not running. It's currently stopped. Okay, now active and inactive are current. Okay, that's what is it currently doing? Is it currently running? Is it currently stopped? That's what active and inactive mean. Okay. Then the last two I want you to know here is enabled and disabled. Okay, enabled and disabled is about boot time. Okay, so active and inactive are current. Is it currently running or not? Enabled and disabled is about boot time. Will it start running at boot time or not? Okay. So an enabled process will start when the system boots up. A disabled process will not be started when the system boots up. Okay. So what you'll most likely see, so let's take a step back. Let's go back to the previous page and look down here at this one. Okay. So what do we see? Okay. Is it loaded? It's loaded. It's enabled. What does that mean? Enabled means the SSHD service should start at boot time. Okay. It's currently active. It's been active since, well, okay, so this document was made a number of years ago, but let's say it was active since Thursday, 2020, November 20th, right, at 11:51. Or no, it's already not 11:51 yet. Let's say 9:20. I don't know. Okay. What we could see from that, what we could assume is what's most likely happened is the system started at this time, the process was enabled at the boot up, and it's been running since then. So one possibility, this is not the only possibility, but one possibility is that the system started up at this time, and that's when this service started running. Okay. Usually when you see an enabled active service, most likely that service was started at boot time and has been running ever since. Okay. If we see a disabled inactive service, most likely that service didn't start at boot time and it's never been started. That's most likely what's happening. Okay. So what I want you to think about, and it may be coming to an assignment or an exam in your near future, would be, what if we have a disabled active service? So it didn't start at boot time, but it's running now. How could that have happened? Or what if we have a service that's enabled, but it's inactive now? So it's enabled, it starts at boot time, but it's inactive. It's not running right now. All right. So think to yourself. This isn't one of those answers in the comments kind of thing. But think to yourself about how that might have happened. And there's more than one possibility. Okay? Because I'll just even tell you. Let's take a look at this one that's right here. Enabled, active. I said most likely it was started at boot time and it's been running ever since. But that's not the only possibility. It could have been started at boot time, stopped at some point, and then restarted. That's a possibility. Another possibility is it was disabled originally, which means it didn't start at boot time. It was started and then it was also enabled around the same time. Right? All different possibilities of how that could have gone on. Okay. All right. So that leads me into the next section of what we're going to be talking about. This controlling system services is how do we change some of that information, right? Because some services, maybe they're disabled now, meaning they won't start at boot time, but we want them to, right? Or what if there's some things that start at boot time, they're enabled, but we don't want them to start at boot time. There's a program on my computer right now that every time I boot this thing up, it starts, and I'm like, I don't use this program. I always have to close it, right? I don't like that. I don't like having to do that. So what I would like to do is change the settings so that it doesn't start at boot time. Okay. So we'll get to talking about some of that. Okay. All right, but that system control command, right? We can use that to be able to tell us information about our services and daemons. Okay, so in the next section we'll talk about controlling them, but right now still some ways to use this system control command, right, to tell us a state of all units at system startup, the state of the service units, which units are in a failed or maintenance state. Okay. Is a particular unit active? Is active, right? Is it enabled? If we want to just know one piece of information about the SSHD command, for example. All right. We want to list the active state of all the loaded units. We want to list them all, even the inactive ones. We want to view enabled and disabled settings for all units. We only want to view the failed services. We can do that. All this we can do. These are all different ways that we can use that system control command. Okay. Again, this is you can learn more about the system D and system control using the manual pages that we talked about how they're getting help in a previous section. Okay. All right. So like I said, we may want to control those things. So it's one thing to learn what is going on with like the SSHD service. There's another thing we might want to do to control it, to get it to do what we want it to do. Okay. All right. So we might want to stop the service. So if we stop this, oh, are we back? Okay, sorry, I think something just hiccuped for a second. You guys hear me? You guys back? Okay. All right. Where were we? Okay, so stopping the service will change its active state from active to inactive. Then when we can take an inactive service and start it. Notice one thing in notes here, the process ID will change. When we start the service that's been stopped or that's inactive, then the process ID will change. It restarts a new version of it, okay? We could stop, and start all in a single command. It's like a restart, okay? Restart the service. So stop it and start it, okay? Now, when this happens, the reason why this is important, the process ID is changed. The reason why this is important is because one of the things that happens when we stop and restart, stop and start a service, or restart it by stopping then starting it, is the configuration file changes. The configuration file is reloaded. So if the configuration file changed, one way that we can get it to reload that configuration file is to stop the service and start it again. But if we want to reload the configuration file without stopping and starting it, right? We don't want to stop the service and then restart it because that could cause some problems. That may not be what we want to do. We just want to reload the new configuration file. This would be like the example of back the what I said a minute ago, the bad example of my kids being outside and the rules change on us suddenly, right? Is I need to bring them in, right? But I don't want to stop and start. Again, I think the kids outside is a very bad example, but I can't come up with a good one right now. It's really much on my mind right now. So all these rule changes, I'm sure it's on all of yours as well. So again, if we want to reload the configuration file, but we don't want to stop and start the service, we can do that using the reload command. A system control reload that service. Process ID will not change. It'll be the same process, just using the newest updated version of the configuration file. Okay. All right. Okay. Sometimes we might have service dependencies, all right, where if something else starts or stops, right, it might be automatically started again by some other process. Okay. So, example, services can be triggered, right, to be started. So we can stop this service, but it's going to tell us that, hey, you can stop that service, but it may be reactivated by some other processes out there. Okay, so we stop this, but you know what? Some other things may happen. It may cause it to come back, even though you don't know about it. Okay. Yeah. Okay. Let's see. This is not. Okay, that's what I wanted to look for. It would look like it was the end of the section here. Okay. What I want to talk also about, in addition to starting and stopping, is we may want to enable or disable services. Okay. So again, remember, active and inactive is about currently running. If we stop a service, we stop it from currently running. If we start a service, we make it currently run. Okay. Enabling is all about what does it do at boot time? What does it do when the system starts up? Okay. So we can use those same system control commands with different extra. Instead of stop, start, restart, reload, right, we can do enable and disable to make that happen. Okay, so we can view the status of a service, again, the same way as before. We talked about this before, status, system control status, to see what's going on, right? We can say disable the SSHD service. Notice, okay, one thing I want you to make sure you notice, when we disable a service, it does not automatically stop the service. Okay? I'm going to say that again. Disabling a service does not stop the service. So what that means is that we have a running service, we disabled it, it's still running. What happens though is if we shut the system down and restart it, it won't start up at boot time. Okay, this disable doesn't change anything about the service currently running. Okay. We can enable the service. If the service is currently disabled, it doesn't start at boot time. We can enable it. In the same way, enabling a service that's not running does not cause the service to run. Okay. So we could have an inactive, a service that's not running. We enable it. It's still not running. If we turn off the system and turn it back on at boot time, it's enabled now. It will start running at boot time. Okay. So again, status tells us information about it. Stop stops it from currently running. Start causes it to start running. Restart stops and starts it all in one shot. Reload takes a running service and reloads the configuration file. Okay. Mask and UMask, those are not as important in my opinion for you guys to know now, but I do want you to know enable and disable. Is enable says next time the system boots up, this service needs to start when the system boots up. Disable says next time the system starts up at boot time, this service should not start when the system boots up. Okay. All right. Okay. By the way, one thing too, one of you may be thinking that there was this question earlier about another section about whether or not we needed to use sudo for this. System control stuff as far as controlling like services and stuff like that does require root privileges, and so our student account, our simple user student account, will not be able to do this on their own. They would have to have root access in order to do these things. Okay. All right. Let's go back to here. Okay. I think what I'll do is, because I've gone through so much today, we won't finish chapter 9 even if there is time. And the reason being that I think that I've given you guys quite a bit to look at for one day. But I do want to at least introduce this chapter, chapter 9, about how to configure OpenSSH. Okay, so SSH stands for Secure Shell. Okay, so the idea is it provides a way for us to run a shell on a remote system. Okay, so if you have a user account on a remote Linux system, that we're talking, again, this stuff is based on CentOS, Red Hat, right, and a couple of others, right? What we can do is, if you have an account on a remote system, you can get into that system, into that computer, right, remotely. So in a sense, it's kind of like a VPN, but VPNs are quite a bit different. Basically, the idea is you can be at home, you can be at another computer in the building, and you can access another computer somewhere else that has things that you need to be able to get to, right? Because not every computer in the network is going to have all the same stuff on it. Okay, so what we can do is we can say, okay, I want to SSH into another server somewhere, into another computer somewhere. So from the computer I'm at, I say, okay, I want to SSH to remote host. Okay. Now, what's going to happen is I type in my password. Now it's going to try to take my user on my current system and find a user on this system that matches. Okay, so it's a student at where I'm currently. I SSH to remote host. It's going to say, okay, you want to log in as student at the remote host. That's what you want to do. So what's the student password on the remote host computer? Knowing that it's not necessarily the same as the password on the current host. All right. Okay, so I type in this password. Now where am I? Oh, I'm student at remote host now. Okay. Now, the way to get back to my current shell, back to my current computer, current location, is to exit. So I type exit, it closes that connection to the remote host, and it comes back to my local machine. Okay. We can also connect to a remote thing, a remote system, as a different user on that other system. Let's say that there is no, on the remote host location, let's say there is no student account, right? Or I don't have a particular account. Well, I can SSH to a particular user at a particular host, at a particular computer on the network. It'll, just like before, it'll ask me for that password. I'll type it in, and I'll be granted access. Okay. Now, what you can also do is, let's say you want to, just like, so if we think of this SSH stuff as being the SU command, okay, the switch user. I want to switch user into another user. In this case, though, instead of being another user, you're actually on another shell, on another computer, on another system somewhere in the network. Okay. We do have an equivalent to the sudo command. So remember, su with no arguments, no username, switches me into what? The root user, right? SSH with just the remote host or just the user at remote host, it'll put me into that user. Okay. But the sudo command, one time, executes as root, just a single command. So what we can do is we can do that as well. So if this up here, if these examples here, this one and this one, if these examples are similar to the su command, this example here is similar to the sudo command. What happens? We SSH as a specific user on a specific system, and we execute a command over there, single command. We give the password for that over there. It executes the command and returns us immediately back to our user on our machine. Okay. As we talked before, this W-F will tell me who's logged in on the current computer. Okay. This is really useful, again, for seeing which users are logged in using SSH. Okay. And what are they doing? So we have these, again, this right here says, I'm local. I'm here. Okay. This right here says, oh, hey, there's this visitor. Interesting. There's this visitor that's logged in from this location using SSH. And I wonder what they're doing logged in. All right. So this can tell us, this can be especially useful if we know that that person doesn't have any business being logged into that computer or something like that. Okay. All right. Again, so this :0 tells us that they're local, right? The graphical login, right? The user currently has 3 terminals open, right? Started by that graphical environment, right? Just terminal windows, right? But there's a visitor logged in to a pseudo terminal, to a terminal 6. And they were logged in at 9:22 today, all right? From some host server 2.example.com, probably using SSH. And it's just been sitting idle at a shell prompt for the past 3 minutes and 14 seconds. Right? So this is all this information that we can know. Visitor, what are they doing? Or how are they accessing? Where are they accessing from? At what time? When have they been accessing? And what's been going on for the past? This is the command they've been running for the past 3 minutes and a little bit more. Okay. So if we saw some other things that might be more concerning, we might consider kicking them off or finding out who it was or something like that. Okay. But this is some information that we can learn about who's logged into our computer, our system, from a remote location. Okay. So one of the things that we're going to get into, and I've just decided that we won't get into the second section, because it has to do with security, and we'll wait till next week for that. But I will finish off this section here today. Okay. All right. So an SSH, right, can send its public key. So Have the students in this course had cybersecurity? Have you had your cybersecurity course yet? I can't remember what year that is. I just don't remember. But the idea, okay, so public key is something you'll learn in cybersecurity. It's about encryption, okay? And when a user uses SSH to connect to a particular server, a particular other system on the network, the command stores that server's public key in the known host file. That way we don't have to always get that key over and over again. Okay? So what'll happen is when you go into that other server, it becomes a known host. You are now known to be over there. Okay, it's a server that you've knowingly logged into before. Okay, so if when they try to log in again, right? To get in, pair it, and then that's a problem. Maybe the traffic is being hijacked, or maybe the server's been compromised. Something's come. It shuts it down. Okay, it says if you've changed, if I'm getting a different public key than I got before, then something may be wrong. Okay. All right. You know, it could be all kinds of reasons that the public key could be changed. Hard drive crash, they had to change public key. Maybe it got replaced because the server was had a risky situation, so they changed public key. All right. So they'll need to update their known host file and remove the old entry. So if we want to see these host IDs, we can use that cat command with the known host file, and we can see what these keys look like. Okay, again, these are all encrypted. These, you know, in other words. All right. But this is a way that we can see what those keys are, and this is what will be compared against anytime I try to log into another server. If it's something I've tried to log into before, it compares the public key it gets then to the public key it already has, and if it's the same, everybody's happy. If it's different, I can't connect. Okay. There is. We'll talk about how to update the host keys, I think, in the next section. Okay. I'm not sure if there's going to be a way today to be able to get the practice going on SSH, because it would require another system connected through the network. So I may have to look into how to do that, and we'll have to do that next week. Okay. All right. So again, I don't say, because I think I've given you guys way too much for one day in this format. And I would also like to use the whiteboard again for how to do some of this stuff, for how this key-based authentication stuff works. But just as a heads up, just as kind of a preview of next week, when we talk about this, SSH is useful for where we can go log into a kind of remote system with our username and password on that remote system. Okay, but kind of like what we talked about here, where if I wanted to run a single command, it can get really frustrating and annoying to try to run this command and have to type in my password every time and have to type in my password every time I want to get over there. It would be much nicer if there was a way to just get over there without having to type in the password, right? We want to be able to, just like the switch user or the sudo command, what I would like to be able to do is just run it, get connected to that remote computer, that remote system, have it run my commands, and be done with it, right? Not have to type the password over and over again. So what we're going to get towards with this section and this section is going to be how to be able to access remote servers without a password. Okay, so again, we won't do that today, but I'm giving that as a little preview for next week. We will end our lecture time there for today, but we still are going to do our practice in the next hour. So I'll go ahead and give the break now. And so in about 10, 15 minutes, we will end our break and we will do our practice for chapter 7 and 8 stuff. Okay. All right. So I'll go ahead and stop the recording now, and we can go ahead and take our break.